In order to prepare for the BIOPAC EMG Lab, you must first complete the EMG Pre-Lab outlined in the Bio 111 Must-Know Lab Manual prior to the lab. The first step outlined in the Pre-Lab is to download the latest version of the free BIOPAC Student Lab or BSL application from the BIOPAC website. Step-by-step downloading instructions are listed on EMG page 2 in your must-know book. If you have any trouble following these steps or prefer a video demonstration with troubleshooting tips, watch the How to Download BIOPAC video tutorial showcasing these steps on the MC Anatomy Physiology YouTube channel. A link to this video can also be found in Canvas under the AMP1 Lab Resources section. If you do not have a computer, however, or are unable to download the application to your computer, the South Hall Upstairs Computer Lab has the free software already installed and can be used to complete the remainder of the pre-lab. If you haven't already downloaded the BSL application, you can pause this video here to complete the downloading steps before continuing. Once the BIOPAC Student Lab application has been downloaded, you can then complete the remainder of the EMG Pre-Lab. Following the instructions on EMG page 3 in your must-know book, open the EMG lesson introduction by first opening the BSL application. Select Prepare for a Lesson at the top of the window that opens, and then Lesson 2 Electromyography EMG from the drop-down list. Select Read Lesson Introduction at the bottom of the window and then click OK. A PDF of the EMG lesson introduction will then open. As outlined in your must-know book, you must read through this introduction as well as the EMG lesson prologue on page 4 and watch the remainder of this video in order to answer the EMG pre-lab questions correctly on pages 5 and 6 in your must-know book. Once you've completed the pre-lab in full, you are then ready to conduct the EMG lab. On the day of the EMG lab, you will be placed in groups of 3 to 4 students. Each group will be provided with the following: a BIOPAC MP36 unit, a recording laptop with power cable, a labeled BIOPAC equipment satchel, and a set of EMG Lab Procedures printed and bound. Please note that these printed instructions must remain in the lab for other sections to use. However, a PDF version of these instructions can also be found in Canvas under the AMP1 Lab Resources section, as well as video tutorial links. Pages 1 through 16 of these instructions detail how to record an EMG for each test subject in your group, which is what you'll be doing in the first half of the lab. Once all EMG recordings for your group are complete, pages 17 through 29 then detail how to open your file on a separate computer to complete data analysis of your EMG recording and answer the EMG post-lab questions in your must-know book. Keep in mind that you will only be responsible for analyzing your own EMG recording. If you cannot record an EMG for a medical or personal reason, speak with your professor before the lab begins. Position the BIOPAC MP36 unit and BIOPAC recording laptop at one end of the lab table near an outlet. Plug in the laptop power cable and turn the laptop on, hitting enter for the password when prompted. Open the BIOPAC satchel and remove the BIOPAC power cable from the back compartment. Please note that this cable is comprised of 2 parts. Ensure the cable is connected firmly at its adapter before plugging one end of the MP36 power cable to the outlet at the end of the lab table and the other end to the DC input on the back of the unit under the DC input label. Ensure that the unit power switch is down and the unit remains turned off while you connect the remaining cables. You can confirm this by checking to make sure the green power light is not yet lit on the front panel under the power label. Now remove the wound USB cable from the USB compartment of the BIOPAC satchel. Note how this cable has 2 different connection ends. Plug in the flat USB end to an empty port on the laptop. Plug in the male type B connection end to the back of the MP36 unit under the USB label. Be sure to match the shape of the cable connection properly here. If this cable end is forced in and plugged in upside down, the laptop will not be able to connect with the BIOPAC unit and you will have errors starting up the software. Now remove the wound electrode lead set cable from the labeled compartment in the BIOPAC satchel. Plug in the prong connection end with the label facing up into channel 1 or CH1 port on the front of the unit under the label for channel 1. Once plugged in, turn the side screws all the way down to secure the cable in place. Next, remove the hand dynamometer from its labeled compartment in the BIOPAC satchel and plug it into the channel 2 port on the front of the unit with the label facing up under the label CH2. And secure it in place with the side screws as previously done. Nothing should be plugged into the electrode check port or channel ports 3 and 4 on the front of the unit. With all cables properly plugged in, now turn the power switch on the back of the BIOPAC unit on. The green power light should light up on the front of the unit under the power label. If the power light does not come on, however, check the cable connections at the DC input of the MP36 unit, the outlet, and the power adapter. If this doesn't correct the issue, ensure that the outlet reset test button hasn't been accidentally pressed, as this can cut power to the outlet. As is stated in the printed EMG Lab Procedures, ask the subject to decide whether they will sit or stand for the length of the EMG recording. The position they select during calibration at the beginning must be maintained throughout all their recording conditions. Have them remove any jewelry on their wrists or fingers, as this may impact recording results and cause discomfort. Remove an electrode strip and the electrode gel from the satchel. Peel an electrode from the plastic strip and check the underside foam that covers the electrode sensor. If the foam appears dried out, press the nozzle of the gel tube into the foam of the electrode and squeeze a small dab into the center of the green foam. Do not squeeze a mound of gel over the top of the foam, however, as this will spread out over the white sticking ring and the electrode will not stick properly to the subject's skin as a result. Preparing electrodes in this manner, place 3 electrodes on the anterior surface of the subject's left and right forearms, following the placement indicated in the EMG Lab Procedures. 2 will be close together near the wrist, and the 3rd will be near the center of the forearm. A total of 6 electrodes will be used per subject. The electrode lead set cable attached to channel 1 has 3 color-coded clip ends. Attach the electrode cable ends to the electrodes on the subject's dominant arm, following the color code shown in the lab instructions. If the subject states that they are ambidextrous, attach the cable ends to the arm the subject writes with best. Ensure the cables have been properly attached and the electrodes are not coming off. Open the BIOPAC Student Lab application on the desktop of the recording laptop. If the BIOPAC registration window opens, just close it out and proceed to the application. Select Lesson 2 Electromyography EMG2 from the menu list and click OK. In the window that opens, type in the subject's first name as the file name and click OK. To protect the subject's privacy, if they do not want their name associated with their EMG recording for any reason, you can type an alternate name of their choosing. Whatever is typed here is what the subject's EMG recording will later be saved as. You are now ready to begin calibration. Calibration requires a 2-second reading of the subject's maximum grip force as is indicated in the example data in the Lab Procedures Manual. Although this is not a recording, this reading is necessary to establish grid lines appropriate to the subject's level of grip force. Please note that every subject in your group will be required to do this before the first recording, with their dominant arm only. Read all the calibration steps allowed to the subject before beginning. Explain to the subject that they will squeeze the hand dynamometer with their dominant arm only as hard as they can from the 2-second time mark to the 4-second time mark, and then nothing else. Again, confirm with the subject whether they will sit or stand for calibration and all experiments that follow. Ensure that the subject's dominant arm is not resting or leaning on any surface before beginning. When ready, click Calibrate at the top or bottom of the screen. A window will appear asking that the hand dynamometer be set down. Ensure that it is flat on the table before you click OK. A second window will then appear, asking that the subject pick up the hand dynamometer and hold it in their dominant hand, but do not squeeze it yet. Give the subject time to do so, and when they have established the proper grip placement, click OK. A blue line will immediately run across the screen above the seconds bar. As soon as the blue line reaches the 2-second time mark, ask the subject to squeeze the hand dynamometer as hard as possible and to hold that squeeze until the line reaches the 4-second time mark. Calibration will then stop automatically after 8 full seconds. Verify that the recording resembles the example data in the lab instructions. There should be only one noticeable clench force running from the 2-second to the 4-second time mark. If the subject squeezed more than once, or the subject did not squeeze as hard as they could, click Redo Calibration and repeat the calibration steps. If there is any error with the recording, you may also review the troubleshooting checklist in the lab instructions before repeating the steps. Once calibration has been properly conducted, click Continue to proceed to the first EMG experiment. The first EMG recording condition will be the dominant arm increasing clench force recording. Read all the recording steps with the subject carefully before beginning, as this condition can be the most challenging to perform. For this recording, the subject must clench the hand dynamometer at a steadily increasing force reaching and holding their clench to specific grid lines at specific intervals. Ensure that the subject has a clear view of the screen before beginning. When ready, click record at the top or bottom of the screen and keep an eye on the running seconds bar. When the seconds bar reaches the 2-second time mark, the subject must clench the hand dynamometer just enough to reach the first horizontal grid line and keep it at that line for 2 full seconds, as best as possible. If the subject overshoots this first grid line, however, click suspend and redo immediately, and have them try again. If the blue clench force line does not begin at the 0 kilogram line, this indicates the hand dynamometer was clenched too soon during calibration. In this circumstance, you must click suspend and then stop, yes in the window that opens, and then done from the screen that appears, to close out the application without saving in order to redo calibration properly. It can be difficult to gauge the accurate amount of force necessary, so redo the recording as often as necessary until the force reaches and holds to the first horizontal grid line. At the 4-second time mark, the subject must then remove their grip force completely and rest for 2 full seconds. You should see the blue line drop back down to 0 during this rest. Then, at the 6-second time mark, they must squeeze the hand dynamometer again, but with slightly greater force to reach the second horizontal grid line and hold that squeeze there for 2 full seconds. Then, at the 8-second time mark, the subject must again rest completely for 2 full seconds. You should now have 2 bars on the screen reaching and holding to 2 different grid lines with 2-second rest intervals in between. The subject must continue this pattern of 2-second increasing clench and hold, followed by 2-second rest intervals, until they are unable to reach the next grid line up that they are aiming for. In this example, the subject stopped after 4 clench bars were recorded, with the 4th bar aiming for the 4th grid line, but being just shy of reaching it. This is a sign that the subject has reached their maximum clench and can go no higher. Note that not all subjects will perform the same number of clench force bars. Click suspend to pause the recording when the subject has reached their maximum. Some subjects will reach their maximum after 2 bars, while others may complete 5 or more. The point is to stop once the subject can go no higher. If the EMG recording does not resemble the staircase pattern, with 2-second squeezes at steadily increasing grid lines and 2-second rest intervals in between, or if you see several bars all hitting the same grid line, then you must click redo and repeat steps 1 through 16 of the dominant arm increasing clench force recording. If there is a proper staircase pattern with rest intervals, click continue to proceed to the next experiment with the dominant arm. Be sure to click continue and not stop. As is warned in the lab instructions, if you click stop before all 4 experiments have been recorded, you will have to exit the program and restart the lesson from calibration. The second experiment is the dominant arm continued clench at maximum force recording. Give the subject 1 to 2 minutes of rest after the first experiment and read all the recording steps with the subject before beginning. For this recording, the subject will clench the hand dynamometer as hard as possible for as long as possible with their dominant arm. When the subject is ready, click record. As soon as the blue line appears on the screen, ask the subject to clench the hand dynamometer as hard as they can and to hold that maximum squeeze for as long as possible. Take note of the subject's maximum force, estimating it with the aid of the kilograms listed for each grid line on the far right of the screen. Once the subject's force decreases well below 50% of their maximum force at the beginning, it is safe to click suspend and pause the recording. To ensure the recording isn't stopped too soon, the subject may also choose to continue clenching until their force is near or at 0. In this example, the subject's maximum clench force was near 18 kilograms of force, which means it would be safe to suspend the recording once they are clearly below 9 kilograms of force, or even below 7 kilograms, just to be safe it wasn't suspended too soon. In this example, the subject elected to clench until they reached failure. If an error occurred during the recording, click redo and give the subject several minutes to recover before repeating the experiment. If the recording resembles the example data, click continue to proceed to the non-dominant arm recordings. Note that subjects may vary greatly in how long they are able to perform the continued clench at maximum force recording. In this example, the subject squeezed within their maximum range for over 30 seconds, but other subjects may squeeze for less or more time. You will now record the same 2 experiments on the non-dominant arm. Disconnect the electrode cable ends on the dominant arm and attach them to the non-dominant arm following the same color code in the EMG Lab Procedures. Read the recording steps with the subject before beginning and establish which line on the screen they will aim for the first 2-second clench. The seconds bar will reflect the total amount of time that has been recorded in the first 2 experiments and will not be reset to 0. Establish with the subject when they are ready to begin clenching based on the time their recording is beginning. In this example, the subject will begin clenching at the 74-second time mark, but this start time will vary between subjects based on the length of the previous recording. Note that calibration is not recorded for the non-dominant arm, being that grid lines have already been established. When ready, click record and once again perform a series of 2-second increasing clenches and 2-second rest intervals. Be sure to create a staircase pattern on the screen, aiming for the next grid line up and holding it there for 2 full seconds and then resting for 2 full seconds. Once the subject is unable to reach the next highest grid line they are aiming for, click suspend to pause the recording. If the recording does not resemble the example data and a clear staircase pattern is not visible, or the subject squeezed multiple times to the same grid line, click redo and repeat the experiment steps. If the recording has a staircase pattern with proper rest intervals, click continue to proceed to the last experiment. Let the subject rest for 1 to 2 minutes while your group once again reads all the non-dominant arm continued clench at maximum force experiment instructions. When the subject is ready, click record. As soon as the blue line is visible on the screen, ask that the subject squeeze the hand dynamometer as hard as they can for as long as possible. Establish their maximum force value in kilograms at the highest peak of the force. When you are certain the subject's clench force has dropped below 50% of their initial maximum force, click suspend. If an error occurred during the recording, or it was stopped too soon, give the subject several minutes to recover before repeating the experiment. If the recording resembles the example data, click stop, as this is the last recording for the subject, and proceed to the saving steps in the lab instructions. Saving must be done after each subject in your group is recorded to ensure data is not lost. Following the saving instructions in the printed EMG Lab Procedures manual provided, click Stop. A window will then appear asking if you are sure you are done recording for this test subject. Click Yes, and then Done in the preceding window. A BIOPAC student lab window will open asking what you would like to do next. Select Copy to another location from the menu and click OK. Please note that if you make any other selection at this time, the entire EMG recording data for this subject could be lost. After selecting Copy to another location, designate a location to save a copy of the file to in the window that opens. If you have a flash drive, plug it into an open USB port on the laptop and select it on the left of the window to view its contents. Click Select Folder at the bottom of the window and do not type anything in the folder field. The file will be saved under the subject's name that was typed in at the beginning of the recording. If you don't have a USB drive, select Desktop on the left of the window, and then click Select Folder. Again, do not type anything in the folder field. You can then visually confirm that the file saved successfully by clicking the File Explorer icon on the bottom of the screen as shown, and then opening either the flash drive or desktop in the preceding window that opens. If you see the file name there, then it has saved to the location you selected, and nothing more needs to be done. Do not attempt to open the file from here, however. It can only be opened via the BSL data analysis application that you downloaded as part of your pre-lab. This step is just to make sure the file is saved before you record the next subject. Once the file is saved, the BIOPAC Student Lab window will again appear. Select Record from another subject from the menu and click OK. A window will then appear asking you to type in a file name for the next subject. Flip back to the beginning of the printed EMG Lab Procedures manual and repeat subject setup, calibration, all 4 recording conditions, and then the saving steps for the next subject. You will repeat these steps for each subject recorded in your group. When your group is done recording all test subjects and each subject's EMG file has been saved to either a USB drive or the desktop, you may then select Quit from the BSL window to close out the application. Any files saved to the desktop should now be visible on the screen. If, however, files are missing, or you get to this point and realize you didn't save properly, there is a step in the saving segment of the instructions that details how to locate a backup file. In most cases, this step will work so long as the system hasn't been shut down. For those with files properly saved to the desktop, you may now open an email account and send yourself your EMG recording file. To save time, you may also send a blast email to everyone in your group with all files attached. Once the email is sent from the recording laptop, each member of the group must then get a laptop from the lab cart or use their own laptop to begin the data analysis phase of the lab, which is detailed in the EMG Lab Procedures manual provided. Before proceeding to the data analysis segment of the lab, if there is another lab occurring after yours, please discard any used electrodes in the trash and leave all equipment attached and neatly arranged at the end of the lab table for the next group. If your class is the last to conduct the EMG lab for the day, however, follow the cleanup procedures listed at the end of the lab procedures. This entails discarding all used electrodes, shutting down the MP36 unit and laptop, unplugging all cables and carefully winding and neatly returning each to their labeled bin compartment in the BIOPAC satchel. This includes the USB cable, the electrode lead set cable, the hand dynamometer, and the BIOPAC power cable. Lastly, return the BIOPAC laptop with its power cable over it, as well as the BIOPAC unit and satchel to the front of the room where your professor can ensure everything is properly put away for the day. You can now proceed to the data analysis instructions in the printed EMG Lab Procedures manual provided. As previously mentioned, a PDF of these instructions is also available in Canvas under AMP1 Lab Resources if you do not finish analysis in lab and need to complete it at home. All of the laptops in the lab cart have the BSL software already installed and may be used to complete the post-lab. It is recommended that you watch the EMG data analysis video tutorial on the MC Anatomy Physiology YouTube channel for step-by-step instructions on how to open your EMG file and complete the EMG post-lab in your must-know book. A link to the data analysis tutorial is available at the end of this video as well as in Canvas.